and welcome to our first online class. We're going to continue where we left off last Thursday. So this is class of the 18th of March and it's class number 84. The first thing I'm going to do is I'm going to correct the homework that was assigned last Thursday. I'm going to leave up the solutions. The best thing to do is to spend a little bit of time going through the solutions with your own answers. If everything matches up, you're happy, that's great. If you have any issues, try and figure out where maybe you went wrong. If you can't figure it out, please just take a picture of the work and send it through to me and I will help you with that. So this is from exercise 11.3 and it's question 12. This is again 11.3 and it's question 13. And this is same exercise and question 19. If you've tried to do something in a different method and want to check that method, please again feel free, just send it over. So we're going to go back to working with this general equation of the circle. So we're at the bottom of page 19 in your log tables. So as we're working through this example, and I'm going to do two different methods, I would love you to have page 19, 18, 19 in your log tables open so we can use it. So we're continuing on with example 5. Now example 5 was a question that anybody who has finished example 4 did start, so you might have this started. We're going to look at two different methods. So show that this line is a tangent to this given circle. So first thing I'm going to do is I'm going to sketch it out and we end up with something like this. So we have a line which is x plus 6y minus 9 equals 0. And we have a circle. Now if that line is a tangent, then we'd be able to put in this line. So this line is the radius and it will be perpendicular to the tangent at that given point. So that's one of our theorems and we can use that fact. So what we're going to do is we're going to see if we can prove it using that idea of the radius. So we're going to see what is the radius of this circle. And then we're going to figure out, well, what is the distance between the center and the line? And if they match, then it's a tangent. If we got two different answers, we could then say, well, if it's smaller, so if the distance between the center and the line is smaller than the radius, it will be a chord. And if the distance between the center and the line is bigger than the radius, then the line wouldn't touch the circle at all. So in order to work through this question, we're going to need to pull out the center and the radius from the circle. So we have x squared plus y squared plus 2gx plus 2fy plus c, and that equals 0. So that gives us 2g is equal to minus 4. So g is equal to minus 2. We have 2f equals 10. So f equals 5. And therefore the center, which is minus g minus f, is going to be 2 minus 5. So that goes in here. We're then going to work out the radius. And the radius is the square root of g squared plus f squared minus c, which is the square root of 2 squared plus minus 5 squared. What's your signs here? Minus, and c is minus 8. And that works out as the square root of 37. So we now know that that is the length of the radius. So now what we're going to do is we're actually going to check to see if the distance between the center point 2 minus 5 and the line x plus 6y minus 9 equals 0, if that matches the radius. Because it says show in the question, it should. So we're going to label this x1, y1, and this is in the form ax plus by plus c equals 0. The formula is the absolute value of ax1 plus by1 plus c all over the square root of a squared plus b squared. Now we're going to fill into that formula, and that's going to give us 1 times 2 plus 6 times minus 5 plus minus 9 all over the square root of, we have 1 squared plus 6 squared. And when we do that, we get the absolute or modulus of minus 37 all over the square root of 37. Now, the absolute value or that modulus means you have to take it as positive, so that's the same thing as 37 all over square root of 37. Now you can put that into your calculator, but basically what we're going to do is we're going to rationalize the denominator. That means multiply the denominator by itself. So effectively we'll get rid of the irrational part, get rid of that third. So we end up with 37 root 37 all over 37. They cancel, so if that went straight into the calculator, you would have just worked out as root 37. So because the radius is equal to the distance between the centre and the line, okay, therefore x plus 6y minus 9 equals 0 is a tangent to the circle. So this is our first method. And it's a nice method. It's usually the easiest of the methods, but it may not be one that might immediately jump to mind, but quite straightforward. So method 2. Method 2 is going to use the idea that a tangent only intersects the circle once. So you have a few different scenarios. You can have a circle and a line, and this line would then be a chord. Red, and this will be a chord. And then you have the scenario like this, which is a tangent. And then you have the scenario here where you have a circle and a line, and there is basically, they don't touch. Okay, so line and circle don't touch. And in each of these cases, we're talking about the number of points of intersection. So this has 2 points of intersection. This has 1 point of intersection. And this has no points of intersection. And when we talk about points of intersection, we're talking about simultaneous equations. So we can do simultaneous equations here, and we can work with these two and work out the points of intersection, and depending on our answer, we'll be able to figure out if it's tangent or not. This is not the nicest way to work, but sometimes it's the way that students will think of in an exam. So as long as you're able to work it some way, there's no big issue in what way you work. Time-wise, the other method would be much, much nicer. So because I have a linear, non-linear, so this is my linear, and this is my non-linear, we're going to work with the linear first, and we're going to isolate a term. So we get x equals 9 minus 6y. I'm now going to sub 1 into 2 now that I've isolated my x. So we get 9 minus 6y squared plus y squared minus 4 times 9 minus 6y plus 10y minus 8 equals 0. And we're going to keep working with that. So we're going to multiply it out. So shortcut for squaring. Square the first, twice the first, by the second, so that's 54,108y plus 36y squared plus y squared minus 36 plus 24y plus 10y minus 8, and that all equals 0. So we're going to do a little bit of cleanup here. There's a y squared and a y squared. There's a y term, and a y term and a y term, and then we'll add our number terms together. So when we do that, we get 37y squared, and that gives me minus 74y, and we get plus 37 equals 0. And we can simplify this, so we can divide across by 37 to make it a little bit easier. So we get y squared minus 2y plus 1 equals 0. You can use guide number for this, and when you use guide number, we get y minus 1, y minus 1 equals 0. We then get y equals 1. At this point, because we only got one value for y, because they're both the same, we can say, well, there's only one point of intersection, or you can keep going with this and sub it in. So then I'll go back to equation 1, and x is equal to 9 minus 6 times 1, which is equal to 3. So the point of intersection is 3, 1. And that's 1 point of intersection. Therefore, x plus 6y minus 9 equals 0 is a tangent to the circle. Now, just in relation to this method, if you're working this way, be aware that we've had quite a nice question because that x had a coefficient of 1 in the linear. If that didn't have a coefficient of 1, we would have ended up with a fraction. Fractions tend to go wrong for students because there's so much to do. They try to get rid of them too early. So in this question, it actually wasn't too bad to go method 2, but look, I would definitely be suggesting that you try and remember method 1, but method 2 is always there as an alternative just in case. So now we're going to look at finding the equation of a tangent. So I'm going to go back to this theorem which we've spoken about a few times, and that is that the tangent is perpendicular to the radius at that given point. And that's going to be hugely important for us to find the equation of the tangent. We should know now if two lines are perpendicular that their slopes are opposite reciprocals. What that means is you take the slope, you flip it, and you change the sign. So we're going to use that fact to help us build the equation, and I'm going to show you another alternative method based off a formula in our log tables. So these are the two formulas that are used to get the equation of the tangent. Generally speaking, they will be quicker. However, students find them confusing, so tend to go back to just figuring it out the longer way. But we say longer way, it's not that much longer because sometimes we can get bogged down here a little bit. I'm going to show you both methods and then you can decide which one you prefer. You should be able to do the second method regardless. So really we're just going to focus in on this one first. So example 1, find the equation of the tangent to this circle at the point 5 minus 5 on the circle. Now that's important because they're giving us the point on the circle. I'm using the second section from page 19. So there's two circle sections. One is where we have the formula with h and k in it for the center, and this has g and f in it. So because the circle equation that they gave us in the actual question matches this section, that's the tangent formula I'm going to use. So I'm going to use this formula here. So first thing I'm going to do is I'm going to take my general equation, 2gx plus 2fy. I like putting it underneath so it's really clear. And then pulling out that we have 2g equals minus 4, therefore g equals minus 2. 2f equals 2, so therefore f equals 1. And c equals minus 20. So in order for us to use this formula, the tangent formula, we're going to need our g, our f, our c, and x1, y1. So we have the point 5 minus 5, and that's going to be x1, excuse me, y1. So our formula then, I'll put it in red so we've a little bit bigger. It's x, x1, plus y, y1, plus g times x plus x1 plus f times y plus y1 plus c equals 0. So just like our usual equation formulas, x and y, we don't sub in for it. So we're going to sub in for x1, y1. We're going to sub in for g for x1, for f for y1, and for c. The x and the y will stay as is, because remember we want the equation of the tangent, so we want it with an x and a y in our answer. So let's go with our substitution. So we get x times 5 plus y times minus 5 plus minus 2 times x plus 5 plus 1 times y minus 5 minus 20 equals 0. And now we do a bit of cleanup. 5x minus 5y minus 2x minus 10 plus y minus 5 minus 20 equals 0. You want to add our like terms, so we have 3x minus 4y, and then we have minus 35 equals 0, and that's the equation of our tangent. So although it looks a bit confusing, this is actually quite a nice little method. So if you're happy with it and able to work with it, yeah, use it as you need to. Now, if you're not a big fan of that, we can go back to looking about how we would work this out using everything we know. So the first thing I do is I'm going to draw my sketch. So I want to find the equation of this line. And if I want to get the equation of a line, I need to use the formula y minus y1 is equal to m bracket x minus x1. So that tells me there are two things that I need to get in order to make the equation. So the first thing I need is a point. Now, luckily, this question told me the point, because they've told me that this is the point 5 minus 5. So I have that. And the second thing, 5 minus 5, the second thing then that we need, so I have that, is the slope. And that's what I'm missing. Now, I know that the radius and the tangent are perpendicular. I know I have the equation, so I should be able to work out the center. So in order to work out the center, I do my x squared plus y squared plus 2gx plus 2fy plus c equals 0. We get 2g equals minus 4. So g equals minus 2. We have 2f equals 2. So f equals 1. The center is minus g minus f. So that is 2 minus 1. So that's my center here. And I know that the red radius that I have here is perpendicular to the line that I want. So therefore, what I'm going to do is I'm going to work out the slope. So I'm going to get the slope between 2 minus 1, that should be a round bracket, and 5 minus 5. It doesn't matter which order you put those in. If you want to have them swapped, it'll work out the same. So x1, y1, x2, y2, and the formula is y2, which is minus 5, minus y1, all over x2 minus x1. And this works out as minus 4 over 3. So therefore, I can work out the perpendicular slope. So it's opposite reciprocal, which means I flip it and I change the sign. So that's 3 over 4. So now I've just worked out my slope, which is 3 over 4. I now have the two pieces of information that I need. So that's my m, there's my x1, y1, and I'm going to make my equation. Y minus y1, so that's plus 5, equals m, so 3 over 4, times x minus 5, multiply both sides by 4, 4y plus 20 equals 3x and minus 15, and that gives me 3x minus 4y minus 35 and that equals 0, and that's the equation of the tangent. So it's a little bit longer, but everything we're doing is quite straightforward. There's nothing very nasty there. It's really about the logic, so making sure you understand the logic. So example 2, find the equations, plural, and really keep an eye out on questions for little hidden like that. So equations of two lines that are parallel to this. Okay, so parallel to this, and which are tangents to that circle. Now that's an interesting circle because this goes back to our basics. So this is a center 0, 0. It's in the format HK. There's nothing there. There's just x squared plus y squared. I also can straight away pull out my radius because the formula initially that we learned was x squared plus y squared equals r squared. So the radius is simply the square root, so the radius is 5. So they've given us a nice circle to work with. So before I can do anything, I'm going to draw it out. And here's my circle. I'm going to fill in a little bit of information. There's 0, 0. It has a radius of 5. I'm not going to put that in yet. But the two tangents I'm looking for are parallel to here. 6 equals 0. Now we talked about the little shortcut for this, but the slope of that line, you can either rearrange it into y equals mx plus c, but we said that another way we could do it is minus the x coefficient over the y coefficient, and that works when it's in the form ax plus by plus c. So it just stops the need for rearranging. It's just a little bit quicker. So I'm looking for two lines parallel to this line that are tangents to the circle. So they're the two lines effectively we're looking for. Now, I have a little bit more information that I can put in here. That's 5. This is also 5. I know that the slope of both of these lines, because it's parallel, is going to be the same as the one above. And I now am able to do a little bit of work. I need to figure out a clever way to work with these because I don't know this point and I don't know that point. I know that the slope is something, but I don't know anything else to put in the equation. So usually with the equations, let's back it up. Usually with the equation, we're looking for two things. We say we want a point, and I don't have that, and a slope, but I do have that. This is one of the situations where actually it will be much easier for us to work with the equation in the form y equals mx plus c. And the reason is I don't know the point, so I don't know the x1 or the y1. So effectively that's two things I don't know. However, if I go into y equals mx plus c, I can sub in for m, so 3 over 4x, and all I'm missing then is c. So it gives me just one unknown. I'm going to multiply across by 4, so that's minus 3x plus 4c. And that effectively is the equation of both lines. So this equation is 4y equals minus 3x plus c, and this is 4y equals minus 3x plus c. And I know that if I measure from the center point 0, 0 to those lines, that the answer should be 5. So I'm going to use the perpendicular distance formula. Now, to use the perpendicular distance formula, we need the equation in a slightly different form. So rearranging it, we get 3x plus 4y minus 4c equals 0. And I'll point out something that hopefully you'll notice, that actually the start of this equation matches the start of the equation we have, because parallel lines, that the x and the y, those coefficients, they should match. So if you wanted, you could go straight for 3x plus 4y plus some constant equals 0. So you could be a little bit more clever than even just pulling out the slope here. Okay, just sorry, this should be 4c and 4c. I've just written it in wrong there on the diagram. Just make sure yours is correct. So I'm going to take the equation that we have, 4y equals minus 3x plus 4c, and I'm going to rearrange it, 3x plus 4y minus 4c equals 0. We're rearranging it so it's in the form of ax plus by plus c equals 0. This is so we can use the perpendicular distance formula. We're measuring from the point 0, 0, so that's x1, y1, and that should equal 5. So basically we're measuring this red line here from 0, 0 to the line, bearing in mind those two lines pretty much have the same equation just with the different c. And when we do that, it should equal 5 because that is the length of the radius. So we get 3 times 0 plus 4 times 0 minus 4c. That's all in our modulus signs. Square root of 3 squared plus 4 squared. So that distance there is the red distance, so it should equal 5. Cleaning that up, we get minus 4c all over 5 equals 5. This gives us minus 4c. 5 by 5 is 25. Now, we need to get two answers here. So how we're going to get two answers is using the idea that the absolute value means that we only take the positive. So minus 4c equals 25. So it's possible that minus 4c was just 25, or maybe minus 4c was actually minus 25 and we changed our sign. In this case, we get minus 25 over 4. In this case, we get 25 over 4. So that's our two values of c. That's how we get two different equations. We go back to the equation. I'm going to use the last form we have, 3x plus 4y minus 4c equals 0. Let's work these one at a time. So the first one is when c is minus 25 over 4. When we sub it in, we get 3x plus 4y. We're multiplying it by minus 4, so that actually gives us plus 25 equals 0. The other one, when c is equal to 25 over 4, what we get is 3x plus 4y. We have a minus 25 equals 0. Now the c's were quite symmetrical there. The only reason that the c's are symmetrical in this question, because it's kind of a coincidence, it won't be in all the questions, it's because we had 0, 0 as our center point. So obviously if 0, 0 is our center point, 5 units to up and 5 units down, we will have this sort of symmetry. So if that center was anything else, we wouldn't have that symmetry, just to be aware. So example 3 is slightly different in the sense that they want the equations, again watch out for those plurals, of the tangent to this circle, which again is a nice circle with center 0, 0, from the point 5, 0. Now notice the use of the word from the point. This is asking for two equations of the tangents. There's going to be two tangents and they've given us a point. This point is not on the circle. So all the hints are there from this point. So that means that the point must be away from the circle. And also the fact that there's two equations, two tangents. If it was a point on the circle, there's only ever one tangent at each point. So we have a scenario that looks like this. We have a circle with center 0, 0. We have a point 5, 0 that's not on the circle, and we're going to have a tangent like this and a second tangent like that. Each of those tangents has a radius that it's perpendicular to, and that's going to be important. Every time I draw in a radius and a tangent, I put in that perpendicular, because that's the hint that a lot of these questions can be answered using the perpendicular distance formula. So we want to find these equations. So in this case, we go back to what do I want and then what do I need. So we want the equation of the tangent. In order to get the equation of a tangent, which is a line, we're going to use y minus y1 equals m bracket x minus x1. And the two things you need to put in there, it's a point, which we know because the 0.50 is on it, and we also need a slope. So we're back to using this equation formula because we know the point. If we don't know the point, if we only know a slope, it's better to use y equals mx plus c, because then we only have one unknown, that's c, rather than x1 and y1. Here our slope is m. So we can work out the equation of each of these lines. So we'll sub in y, I'm going to label this one first, x1, y1. So we get y minus 0 equals m bracket x minus 5, and that gives us y equals mx minus 5m. Rearranging this in a format we can use for a perpendicular distance formula is mx minus y minus 5m equals 0. So that's now in the form of ax plus by plus c equals 0. Now I know that if I, just like in the last question, if we measure from the center 0, 0 out to either of these tangents, that we should be able to get the radius. Now the radius, x squared plus y squared equals r squared, so that radius is going to be the square root of 5. So the answer there should be the square root of 5. So I'm going to measure from the point 0, 0, that's x1, y1, and that distance will be square root of 5. So we have a times x1 plus b, it's minus 1 now, be careful there, y, 0 minus 5m all over the square root of m squared plus minus 1 squared, and that should equal the square root of 5. Doing a little bit of cleanup, we have minus 5m in our absolute value signs all over m squared plus 1, and that equals the square root of 5. I'm going to just work over here if I can. I'm going to get rid of that fraction, so I get minus 5m in absolute value signs, and it's square root of 5 times the square root of m squared plus 1. Now, laws of surds tell us that we can actually combine those and multiply underneath the square roots. That's 5m squared plus 5. Now, we have the modulus or absolute value signs, and we have a square root. So the easiest way to get rid of both is we're going to square both sides. But be really clear about what happens. The square cancels with the square root. However, this thing in our absolute value sign must be multiplied, or must be squared. So we get 25m squared equals 5m squared plus 5. So going, let's bring everything to the left. So we get 20m squared. Actually, I'll now leave the constant over here. So m squared is 5 divided by 20. That gives us a simple 1/4. So m is equal to half. Now, just be really careful when we're doing that. Sorry, so when I've done that on the wrong line. When we're doing the square root, we must put a plus, a minus in front of it. So my two answers for slope are plus and minus a half. So now that I have my two answers for m, I can go back to my equation in terms of m and sub it in to find the equation of the tangent. So let's start with m equals a half. So that's a half x minus y minus 5 times a half equals 0. Multiply by 2, so x minus 2y minus 5 equals 0. and then m equals minus a half. Again, we have a symmetry in this question. The reason we have the symmetry is because that center is 0, 0. That won't always happen. So don't assume that the slopes will always just be kind of the opposites of each other. I'm going to multiply across by minus 2 this time. So that gives me plus 2y. That's minus 5. So plus minus, and that equals 0. So our two equations are x minus 2y minus 5 equals 0, x plus 2y minus 5 equals 0. So our final example for today is finding the length of a tangent to a circle from a given point. So find the length of a tangent from the point minus 5a to the circle, which is this one here. So I'm going to draw that out. Again, this point is not on the circle, so we have a situation like this. This is the point minus 5a. We'll work out the centre in a minute. And there are two different tangents that come from that point that touch the circle. They're each a distance r away from the centre, and the radius and the tangent are perpendicular at the same point. And they want us to find the length of the tangent. So what we're basically trying to find, it doesn't matter which one we work with, is either this length here or the equivalent length on the other side. Now, we've already worked with getting the equation. You get the equation and then do some fancy stuff, but there's a much easier method, and it comes from the fact that we've our right angle here. And to do this method, you need to connect the center with 5/8, and effectively what we make is a right angle triangle. We have a right angle triangle where we actually know a lot of that information. So I'm going to go to my question, and I'm going to work with this circle to find the center and the radius. So plus 2gx plus 2fy plus c equals 0. So we get 2g equals minus 4, so g equals minus 2. 2f equals minus 6, so f equals minus 3, and c equals 3. So the center, which is minus g minus f, is 2, 3. So that goes here, 2, 3. The radius, if we want to work that out, is the square root of g squared plus f squared minus c, and that is square root of 10. So that works out as our radius. So I'll put this in red, root 10. Now, because we have a right angle triangle, we're going to use that fact to work out the green side. So if we were talking about Pythagoras, and I'll change colour, this would be the hypotenuse, so C, and that's A and that's B. So Pythagoras would be C squared equals A squared plus B squared. Now the only issue is I don't know C either. However, we can work that out quite easily because I have 2 points. So we're trying to find the length of C, so the distance between 2, 3 and minus 5, 8. So that's the distance formula that's on page 18. So we have x1, y1, x2, y2. So C is going to be equal to x2 minus x1 squared plus y2 minus y1 squared. If you want, you can go straight to c squared because that's what you're going to need for your answer, but we'll just work out the length here. So that is 49 plus 25. So that's the square root of 74. So then coming along to do Pythagoras, we have the square root of 74 squared is equal to a, which is root 10 squared, plus b squared. So b, when we work it out, so 74 minus 10, so 64, square root of 64, so that is 8 units, and that is the length of the tangent. So So you could, if you wanted to go and get the equation of the tangents, work with one of the tangents, figure out then that point, and then work out using the distance formula. But this is so much easier. It is, I suppose, maybe not as obvious as other methods, but it's definitely the easiest. So don't forget that that right angle often means that we can make a right angle triangle, and anytime we have a right angle triangle, we can use Pythagoras. I'm going to assign some work based off these examples, and I'll do that using Teams, so make sure you check there to see what to complete for the next day. Any questions you can ask me through Teams as well.